A force can be described as a push or pull and contains three independent properties that define it. First is magnitude, which is how large or small the force is. Second is direction, or in other words, which way the force is applied, and this determines where the object is traveling. Third is location, which is the place on the object where the force is being applied at. We represent forces with arrows and vectors since forces have a direction and not only a magnitude. Complete this mini activity on your own to become familiar with the three properties of a force. Find a small object in your house. A good example would be a textbook or book. Lay the object down on a flat surface. Using your hand, push at the center of one of the faces of the object with a consistent magnitude and direction. Use this as your reference experiment. Next, keeping the location and direction the same, change only the magnitude of the force you are pushing with. Observe any differences. Now, change the direction of the force, but keep the location and magnitude the same as your first experiment. Finally, change the location on the face at which you are applying the force, but use the same magnitude and direction as the reference experiment. Write down any of your observations. Here we will assume the object is the gray box, and the arrow represents the corresponding magnitude, direction, and location of the force applied. For the reference experiment, we will apply a force to the center of one of the faces of the box, labeled C, and in a direction to the right. The box will travel to the right in a straight line. When we increase the magnitude of the force by drawing a larger arrow but keep everything else the same, you should observe that the movement path will increase compared to before. Similarly, keep in mind that if you decrease the force, the movement path will also decrease. Next, we will change the direction of the force by drawing an arrow going left, in the opposite direction as before. Observe that the box will now travel in a straight line to the left instead. Lastly, we will apply the force not at the center but to the right of the face of the box. The box now portrays rotational movement to the left instead of traveling in a straight line, similar to the dotted line I have drawn. Here is an example for the activity. First, a force is being applied that moves the textbook in a straight line forward. When the force is applied to another side of the textbook, it now moves in a straight line to the right. Finally, when the force is applied to the right of the face of the textbook, it now moves in a curved line.